So we're going to start off today's lecture with a quiz on Chapter 5's contents. These questions might be tough. You do know the answer. It's just the wording might throw you off. But take your time, think about them. You are developing an application that responds to mouse movements. Which programming structure would you use to achieve this? Okay, I did say they would be tough, but this one's not so bad, I don't think. This one you've, in a way, seen. Okay, cool. So 2 out of 3, not bad. Let's hope that would reflect the broader class as well. I see, Bryn, you just joined. Okay, we're in the first Mentimeter question. Please join the quiz. You can see the details at the top and in the chat. And then just let me know in the chat when you've joined or through your mic or something. So we'll just wait for you. But yeah, okay, so this first one's not too bad, right? Mouse movements are just an event, right? So it doesn't show the Menti meeting. Oh yeah, sorry about that. Yeah, thanks, Kreflo. So, I see Pertis here too, cool. So we've got quite a squad here today, actually, dang. So guys, the details are at the top of the Menti slide as well. You can see it says go to menti.com and use the code 9262 227. Yeah, that's one. All right, let me just move this. I don't know if you guys can see it. I don't think you can. But yeah, so you can see it at the top of the slide as well. Yeah, and just let me know when you're in. But yeah, okay, so this first question, not too bad, right? Mouse movements are an event, just like a mouse click or a mouse drag or a keystroke, or basically everything in a way in applications are done with events, like any inputs are done with events, but then even something like a user logging in would probably be done with an event. So yeah, this one, not too bad, but the questions I was asking do get a little bit tougher than this. But yeah, so take this quiz as more of like a introductory, or not introductory, but like a revisory thing. It's supposed to help us revise and familiar ourselves with the questions. So Bryn, have you joined the quiz? Are you in? Perty, do you want to join the quiz as well? So you can see at the top of the slide there's the details for it. So if you go on like your phone or something, www.menti.com, and type in where it asks. Okay, shall we just go on to the next question? People are here, so they can see the solutions and stuff. That's far away. Cool. Okay. Yeah, I see you there. Awesome. All right. On to the next one. You want an application that provides multiple windows. It does not need to work effectively across multiple monitors. What should you use? Oh, dang, Jack Jones is here. That's cool. What's up? It's been a while since I've seen you at a lecture, I think. Mentimeter quiz. So let me say, like, go on your cell phone or something and visit like another device and go to www.menti.com and say 9262227. Like that. Okay. Oh, wow. Okay, most of you got it. I guess in a way I gave this one to you because I said that it requires multiple windows, but please take note of what I'm about to say, guys, because you might have been thrown off if I worded this differently. Okay, so what I asked you, I said you want an application that provides multiple windows. Now you might think, oh, that means we want a MDI application, right? And you wouldn't be totally wrong, but the next part does matter. The fact that I say it does not need to work effectively across multiple monitors means that, okay, cool, an MDI application with one instance will work because I just open exactly like my my browser here. Like I can open one instance. So I have one Google Chrome open. You can see on the left, I have one Google Chrome open, and I can open up multiple windows inside this one instance of Google Chrome, right? So that's cool. But understand that number one, an MDI application is very difficult. And by very difficult, I mean essentially impossible to get it working across multiple monitors. So if this question said, you want an application that provides multiple windows, but it needs to work effectively across multiple monitors, you would instead say an SDI application with multiple instances, okay? Because remember, the other way that you can get multiple windows is just by opening up multiple copies of the same application, right? Like if I open up another Google Chrome here, or if I open up 2 of whatever programs, I'll have multiple windows, but they'll be SDI applications, right? They could be SDI applications. Okay, like if we open up multiple calculators, and those it's easy to move across multiple monitors. So please remember, if you didn't get what I just told you, then maybe tell me. But so an SDI with one instance, that couldn't have multiple windows, right? Because one instance of an SDI is one window, and the SDI has no way of spawning more windows. An MDI with multiple instances is just overkill, right? Because then you can have multiple windows in multiple windows, which is a bit crazy. So the answer is either SDI with multiple instances or MDI with one instance. And because it says it does not need to work effectively across multiple monitors, it's MDI with one instance. Okay, cool. Anyway, hopefully that makes sense to you guys. Let's jump on to the next one. Cool. So question 3 of 5. You are creating an application with no interfaces that logs information to a text file. It must be easy to install and program. Okay, it should say program, not programs. How can this be done? Okay, guys, so this one, yeah, I have a feeling this one might throw some people off. Hopefully I haven't given away too much information already by just saying that. Because you might think this is a fairly easy question, but that's why I'm showing it to you. Okay, that's why I'm showing it to you. Yeah, okay, cool. So this is why I showed it to you. Don't worry if you got this one wrong. I understand this one is a bit hectic. Okay. So they give you a lot of conflicting information here, right? So they say you're creating an application with no interface. Again, when you read that, just like I probably would in your shoes, you'll immediately think Windows service, right? Because a Windows service has no interfaces. Oh, sorry, I need a glass of water. So yeah, a Windows service has no interfaces. But the next bits of information it gives you are the reason why it's not a Windows service, okay? So number one, they say logs information to a text file. Now you have been shown this. A Windows service can only log to the event viewer, okay? To the event log, rather. It can only log to the event log, okay? Not to a text file. Secondly, Windows services are not easy to install and program, okay? I mean, again, when you saw Windows services, maybe they seemed pretty easy to install and program because we had a fairly simple service and it didn't take us too long to install it. But you can see that there's definitely more steps involved in it running and installing a Windows service than there is in running a console-based application. Okay, so I know, tough question. You'll see how else they can phrase this a bit later, but that's why I wanted to show you this quiz, to introduce you to this kind of wording, because honestly, this test doesn't matter. Your final test is what matters, okay? So keep everything in context, okay? Okay, question 4 of 5. We are using an installer to install 2 Windows services, 2 of them, with the same account type. In which class would the account property be specified? Okay, I'm sorry, I was just logged out. I don't know why. Check the schedule, people. Okay, there we go. Sorry about that, guys. Everyone's still here, right? Nothing bad happened. Yeah, cool. Oof. Tough one. Okay. I did tell you this. I'm not too surprised, I guess. So there's 2 classes, but this is why this is good for revision. This test is good for revision. There are 2 classes involved when installing services. Okay. There is the service installer class. So this one on the left, the service installer class. And there's the service process installer class. So service installer and service process installer. Those are the two you must remember. The service process installer specifies things for all of the services you are installing, like the account type. Okay, so if we have an application with 5 services or 3 services or 2 services, the service process installer specifies information for all of the services we're installing. Each service that we are installing has its own service installer class. So the service process installer is for all the services, but each one has its own service installer. Okay. And the service installer class specifies information specific to the application. From last week's lecture, do any of you remember? Can you give me an example of what kind of property we would specify in the service installer class for service specific things? What kind of information did we have in that service installer class? Does anyone remember? I'll give you guys some time, because remember there were 4 things that we looked at. So one of them was account type. So that was the local service, local system, network service, or user. And there were 3 other properties that you could specify in this service installer class. So the service process installer class had account type, and there were 3 other properties that we looked at that are in the service installer class. And they're all specific to the service that you're installing, specific to one service. So what were those 3 properties? Does anyone remember? Or even one of them? And in fact, you could even guess on this one, kind of, like what would be something that is service specific to a single service when you're installing it? I'm pretty sure one of the properties we specified to be one of your names, actually. Okay, so the service installer class contains the display name, the description, and the start type. Okay, so manual, automatic, or display. Those are the 3 properties that the service installer class contains. All right. The service and process installer class contains things relevant for all of the applications, which is basically just accounts. Okay, just the account property. Okay, cool. On to the last question. In a similar vein, let's jump in. I see someone DC'd from the test. After we install the 2 services in the previous question, where would we view the messages that they post to the event log? So we've installed these 2 services. Where do we view the messages that they now post? Okay, cool. Everyone got that one. Okay, great stuff. Yeah, that's that for the test, guys. Nicely done. That wasn't too bad, I don't think. Bryn, did you DC at the end? I don't know, because there's only 3 people left in the test now. Oh, wow, this is a change of pace. Hey, yo. Nicely done, Cref. So that's 4 right. So that's very good. Taddy, you got 2. That's good. Tariq, nicely done. Huh? Interesting. Interesting. That is a change of pace. A little bit. Okay. All right, guys, nicely done. Happy with that. So on to relational databases. So cool. After that, slow internet plus slow phone. Okay, fair enough. Let me just see. So, oh, I don't know why it's not allowing me to move this thing now. Oh my gosh, Zoom, what are you doing? What are you doing? Okay, unfortunately, Zoom is not allowing me to move the little. Okay, there we go. Finally. Okay, cool. Yeah, I'm ready to get started. Let's see. So, okay, cool. We got through the test pretty fast. It took that long, Creflo. It's so nice. I convinced my gran to get fiber long ago, like when it first came to our area. We just immediately canceled the STV and got fiber instead. So much better. Because you can get like everything you need online now. Just news, entertainment, all of it. You don't need anything else. It's like basically the only important expense is fiber. Okay, cool. Let's jump in. So guys, databases, that's what chapter 6 is on, the last chapter of the course. It's pretty interesting. I will also be posting on the group because the higher ups at Brighter Futures made like a cool interactive test project type thing for you guys to work through to learn databases. So there's 3 parts. We're starting with the first part today, which is just understanding databases, because there's a lot of words involved. Like you'll probably, we are in a slightly different situation now, right? Because I'm back to using my laptop now because I no longer need the Windows features for this lecture in particular. So that probably suggests to you this will be more theoretical. We're going to be learning a lot of the words, the names, the concepts that are required before you can even start studying databases. And then next week, we'll be back to programming and things like that. Okay. But yeah, today will be a very thinking cerebral lecture, if you like. Okay. So number one, what is a database? I imagine you guys have a pretty decent understanding of what this is, right? We interact with them every single day. A database is an organized collection of interrelated data. So, I mean, really, you could just say a collection of data, basically. But obviously, it's going to be organized, or then it would be worthless, and the data has to be related somehow, or then why would it even be in the same database? So, yeah, makes sense as a basic definition. Turns out no one really uses that particular understanding of a database. Nowadays, we have a thing called a relational database, and that's really what we're going to be covering in chapter 6. There is a new kind of database that Google is trying to introduce with Google Cloud, but we're not covering that. The standard across the vast majority of websites that you'll ever be using and interacting with is just a normal relational database, okay? So a relational database is also just an organized collection of interrelated data. The way that it's different is how it proposes a certain way of organizing that data. So that word organized collection is pretty vague. When it comes to a relational database, it's much more specific. The data is organized according to 3 things. Ooh, sorry, was someone asking a question? Didn't hear. Never mind. And it organizes it according to 3 things: entities, attributes, relationships. And you'll actually have a fairly decent understanding of these 3 things when we start discussing them more. Okay. So the first thing, we just have to get some terminology out of the way. As usual, when we start a chapter, there's just some terms that we have to introduce. So one of them is DBMS, Database Management System. Pretty easy acronym to remember, I think. The database management system is what we use to create, access, store, backup, and manage databases, okay, as the name sort of implies. There's also, since we are using relational databases, every single database management system that we'll be interacting with use relational databases. So we call them relational DBMSs. But really, because most databases nowadays are RDBMS, relational DBMSs, it doesn't really matter to say relational nowadays. It's one of those things similar to back in the course when they were introducing JavaScript as exclusively client-side. It's a little bit like of an outdated logic because nowadays everything's relational, so you don't have to really mention it. But that does make it a very important idea to understand. Okay, so what we're going to start with, I think now that we've got some basic definitions out of the way, the best way to understand this is to actually just create a relational database, and you guys will see that they're not really that scary. So they propose in your textbook, I think this is on page, where is it? It's on page 144. I turned it into a pretty nice graphic. You'll notice there's a lot of text on these slides because I've made them to be like study notes, essentially. Basically, everything in your book from the first portion of chapter 6 is in these slides directly. So you'll be able to study from them quite easily. So this is the 6-step process that's on page 144 of your book of how to create a relational database. Okay, so the first one is create a mission statement. So basically, I mean, it kind of goes without saying this first step because, like, obviously you need a purpose, right? Like you wouldn't be creating a database if it didn't have a purpose. So that first step is just figuring out whether you need, want, or why you want a database, okay? So it makes sense that you would start there. Then these 4 steps, okay? So determine the data that needs to be stored. What data do I need to store in my database? How much of it do I need to store? Take that data and you'll divide it into tables and columns. We'll discuss those later. Yeah, you don't have to have a clear understanding of that yet, although you know what a table is. And here, when we say table, it means exactly what you think about as table, right? There's columns and there's rows. That's all we mean by table. Choose the primary keys. So the primary key is the aspect of the data that you'll use to uniquely identify each option. So for example, if we're creating a database of all South Africans, we might say that the primary key is each South African's ID number. The ID number is the primary key because we uniquely identify each South African by their ID number, right? Makes sense. That's the primary key. For a book, it might be the ISBN number, something like that, okay? And then identify relationships. So that's how is each part of your data connected to other parts of your data. And then we do something called normalization, which we'll discuss towards the end of this lecture. Turns out, quite conveniently, all 4 of these middle steps can be combined into a single process, okay, called entity relation modeling. So, we do entity relation modeling by creating these diagrams called entity relationship diagrams. Entity relationship diagrams, or ERDs for short. So we're going to see some ERDs now and figure out exactly how they make it easier for us to create databases. Okay. So that's what we're doing now. We're doing these middle 4 steps by creating some entity relationship diagrams. You can see, so they give you one example of this entire process of going through and creating a database in your book, starting on page 145. At the middle of page 135, they have an ERD. I'm going to do a different example in the slides. So you'll have like 2 examples to reference while you're studying, okay? So entity relationship diagrams. All right, let's jump in. So relational databases organize data by defining the data as entities. Okay, so entities, not a word that you're not familiar with, but you'll see that it connects really well to a concept that you do know. It also defines their attributes. Okay, you have heard that term before, which is interesting, and we'll expand on that in a bit, and the relationships between the entities. Okay, so what do we mean by this? So an ERD takes these 3 attributes, okay, so entities, attributes, relationships, these 3 items, and it combines them in a nice graphical way to display what the database will do and what it'll look like, okay. So cool, let's discuss what each of these 3 things are, because we've kind of just glossed over them now. So relational databases are made up of these 3 different important concepts: entities, attributes, and relationships. And ERDs also display that because they're how we model relational databases. Okay, so what is an entity? An entity is a construct that represents a physical object or concept. Okay, so an entity is something that represents a physical object or a concept. Entities are named for the nouns that they represent. So, for example, a book, a customer, a publisher, an order. So guys, just from hearing this definition of entity, can any of you connect it to an idea that you've heard before? It's a construct that represents a physical object or concept. It's a construct that represents a concept. For example, a book, customer, perhaps person, tree. Abstract, well, so more specifically than that, so or less specifically in a way, in a way an abstract class would do, right? This is essentially describing a class, right? It represents a concept. Precisely, yeah, nicely done. Attribute. Okay, so we have these entities, these constructs, and they're basically what you guys already know as classes. And I'm telling you, it's the same thing. Okay, it's the same thing. An attribute, the properties that make up or define an entity. Okay, notice so we use the word attribute to describe these things. And in the definition, we say the properties that make up or define an entity. The word properties, you guys should recognize, right? Classes have properties. Likewise, entities have properties. So again, guys, the idea of an entity, the idea of an attribute, you guys are familiar with those. Entity just means class, basically, and attribute just means property. Okay. So you guys are already familiar with these ideas of relational databases. And in an ERD diagram, entities will be represented with rectangles, attributes will be represented with ellipses. Okay, the last thing, which you guys are not familiar with, because this doesn't really exist in object-oriented programming, or at least it doesn't exist in a nice way. Like it's much nicer in databases how this is done, called a relationship. Okay, so all this means is it's usually a verb of some sort. So for example, a publisher releases a book, a customer places an order, a person reads a book, right? So like these kinds of ideas, these verbs are relationships, right? Because we have an entity called publisher, we have an entity called book, and the publisher publishes the book. Okay, so it's describing a relationship between publishers and books. Likewise, we have this entity called the customer, we have another entity called an order, and a customer places an order. Okay, so there's a relationship between these entities. The relationship between customers and orders is places. Okay, so cool. All of these things can be displayed in an ERD diagram. Okay, and it would look like that. So here's one ERD diagram. There's another one in your book on page 145. So this ERD diagram, fairly simple, really. So we have a publisher. Okay, so publisher, as you can see, it's a rectangle, right? Because entities are represented by rectangles. The book is also a rectangle because it's another entity. Okay. The publisher has three attributes. It has ID, name, and city. Likewise, the book has three attributes: ISBN, title, and author. Okay. The diamond between them represents a relationship between publishers and books. Okay. So a publisher releases books. Okay. Or publisher releases book. Now, notice there's also this 1 and an N. Okay. 1N. 1N. So that means that there is one publisher and N means many. Okay. The N represents many. So one publisher releases many books. Okay. That's the relationship. Publisher releases books. Okay. You get it. So 1N, that's saying it's a one-to-many relationship. You could also have a one-to-one relationship, right? If, let's say, we lived in a weird world where each publisher could only publish one book and only one book, then it would be 1-1. Okay, so one-to-one relationship. Okay. Cool. So that's an ERD diagram, guys. And once you have this ERD diagram, so like we were saying, what we came into this trying to do is these middle 4 steps here. Okay. So this ERD diagram must help us do all 4 of these steps. Okay. And that's what it does. So we've now basically designed a relational database just by drawing this simple diagram. Okay. Notice that under publisher, ID, the attribute ID is underlined. And under book, the attribute ISBN is underlined. Usually, the underlined attribute is what we call the primary key. So each book in our database is uniquely identified by its ISBN number. And each publisher in our database is uniquely identified by their publisher ID number. Okay, so that's one important idea to get behind there. What's the time? Okay, cool. We've still got plenty of time before our break. Okay, so once you've got this ERD diagram, it's actually super easy to convert it into a relational database. Okay, so we now just want to take this diagram and actually convert it into a database. So how do we do it? There's just 2 steps. Once you have the ERD diagram, there's only 2 steps on how to convert it into a database. So the first is you map the entities to a table. Okay, so each entity becomes a table. So we're going to have a table for all of our publishers and a table for our books. Okay, so 2 tables, a publisher table and a book table. Okay, each column in the table, so each attribute will define one column. So there'll be a column for ISBN, a column for the book's title, and a column for the book's author. Okay, and the primary keys are the underlined ones. You'll see what that looks like in a table now, so don't worry about it too much. Okay, and then, so that's the first step. We map each entity to a table, and that's a fairly simple process to do. And then we have step 2. Okay, that's then mapping the relationship. So we have this relationship between publishers and books, and what we have to do is we say the table on the N side, so book, each book is also going to have a column that references the ID of the publisher that published it. It'll make more sense when you see it on a table now. So what we're going to do is we're going to follow these two steps on the next slide. We're going to follow those two steps, and we're going to convert this ERD that we have on the left. And you can see I just added another attribute to the book. So the book now has 4 attributes. It also has a genre, but that's a simple addition. It's just adding another column to our table. Okay. We're going to take that ERD on the left there, and we're going to turn it into a database. Okay. And you'll see that it's actually very simple. So I'm creating a publisher table. Okay. So there we go. We've got a publisher table. You can see each column in the table takes on the name of the attributes. So there's a column for IDs, there's a column for the names of our publishers, and there's a column for the cities of our publishers. And guys, notice, so this could be any data, right? Any publishers could go here. I just chose 3 random publishers to put in our database. Okay, I just chose these. They're fairly arbitrary. You could pick different publishers if you wanted. Okay, cool. And we then also have a table for our books. Okay, we have a table for our books. Someone tell me how many columns, just to make sure that you guys are concentrating, how many columns are in this book table, guys? How many columns are in this book table? There's 5 columns in the book table, precisely. Why is that weird? So how many attributes does the book have in the entity relationship diagram? In our ERD diagram, how many attributes does book have? 4. Exactly. So it has one extra column. Now, why does it have that extra column? It's because of this guy right here. Okay. The relationship. Book is on the N side of the relationship, which means we need this extra column over here called publisher ID. Okay. Publisher ID. So all this column does is it tells you the ID number of the publisher that published that book. Okay. So this column was put there by step 2. If you remember, like on the previous slide, step 2 was map the relationship. Okay. So let's understand why this exists in this way and what information this is telling us. So you can see both of them. So in the column, in the book, let me just say in the ERD diagram, just to simplify things, you can see I replaced it with ID. It's no longer ISBN. The reason I replaced it with ID is because that just allows me to type one number instead of a whole long ISBN number. But you can imagine the primary key being the ISBN. It'll be the same. Okay. So cool. What is this telling us? Number 1, so the primary keys of each table. So the publisher table, the primary key is ID. And in the book table, the primary key is also ID. So each item in each of these tables is uniquely identifiable by its primary key. So you can see if I ask you for, let's see, actually, you guys will probably be able to read this already. I want the title of book 2. Can someone type the title of book 2? The title of book 2. Can anyone read that off this table here? Metamorphosis, precisely. So how do we see that? The primary key of book is this column here. We go to the second one because the primary key is uniquely identifying each book, and we get out metamorphosis. Okay, easy peasy, right? That's how you read a database. The primary key uniquely identifies each row of your database. Okay, so now let's do something a little bit more complicated. Let's use our relationship here. So I want the publisher. What city does the publisher of book 3 come from? What city does the publisher of book 3 come from? Can anyone do that? Slightly more complicated.
Springfield.
Springfield, precisely. Yeah, that was pretty easy. Cool, nicely done. So how did we do that? We went to the ID of book 3 that uniquely identifies each row. Okay. We went to the publisher ID and we found that book 3 is published by publisher 1. We jump up to publisher 1 and we see that their city is Springfield. Okay, easy peasy. Cool. So that's how you read a database, guys. I trust you guys see this as pretty simple, and it is. Slightly more difficult to code, which we'll see in the next lecture, but still quite easy. SQL is quite a nice language. I think you guys will pick it up quite fast. But before we have to do that, we have to discuss. So this database looks perfectly all right, right? So it looks like it'll work as a database. So this is a working relational database. It's very easy. All we had to do was make an ERD diagram. But remember that there's that last step. And so we have to discuss that last step a bit, because it turns out that this little database we've created on the right here is actually awful. Okay, this is a very bad database. This is not how you would do it professionally. This is a good place to start. So we created the ERD diagram. We've got the data that we want in these tables. But this would not actually work as a database. So we're going to discuss why and also how we can fix it. So the entity relationship modeling allowed us to do these middle 4 steps, but we still have this one last step on the right here. Okay, and it says normalize the database, resolve issues that may affect data integrity. And yeah, we're going to learn the rules of how to do that. So what is normalization? We normalize databases to protect data integrity from what we call anomalies, okay? And it also improves the ease with which you can maintain the database, which we say ease of maintenance, okay? So the ease of maintenance of the database. So let's take our little table on the right here, okay? This is this book table that we created. It seems like it's working perfectly fine. By the way, I just removed the publisher ID and I added an ID for genre. Okay, so again, I'm morphing around the table a little bit, but you can still read this fairly easily. The primary key is still ID. Okay, this ID column over here, and it's just ID. That's the entire primary key is just ID. That uniquely identifies each row. Okay, so why is this database actually terrible? So there are 3 different kinds of anomalies that can occur if your database has not been normalized. So we're going to go through each of the 3 anomalies, see their names, and see how they affect us. Okay. So the first one is called an insert anomaly. An insert anomaly. So this occurs when we're not able to insert new data into our database because some of the because there's an unrelated dependency. Okay, so we'll discuss dependencies later, but there's a very easy way to insert to understand this with this table over here. So you can see on the right here, all of our books have a genre, right? They all have a genre. You can see over there. So we've got a genre called poetry, we've got a genre called fiction, and we've got another genre called fiction. Okay. So let's say hypothetically, we wanted to add another genre to this database. Okay. So I just want to add another genre. Let's say I want to add genre 3. Okay. I want to add genre 3. And we're going to call it history. So we're going to have a historical genre. Historical. Okay, something like that. So I would add just this little row at the bottom here. That's what I want to do. Now, guys, what problem do you notice here? If I wanted to add just this extra little piece of information at the bottom here, another genre, what problem do I have with how this database is designed? Yeah, exactly. There's all of this information, right? So you need, essentially, the problem we're running into here is if you want to add a new genre to the database, right, like a new genre, you have to have a book of that genre, right? Like if I don't have any historical books, the historical genre cannot exist in this database because you need a title, you need an author, and you need an ID for a book. Okay, so that's what we mean by like unrelated dependency. The genre is not directly related to the book in this way, right? There is a relationship between them, but like genres do not require books to exist, if that makes sense. Like in this sort of logical example, I should be able to add a genre to my database without having a book from that genre, right? Hypothetically, I should be able to add a book without it even necessarily having a genre, maybe if you wanted, like a default genre or something. So having like this kind of weird relation here means that you need to know more about your data than you sometimes would. Okay. So yeah, cool. That's the first thing. So that's an insert anomaly. It means we're unable to insert new data because it requires other data to exist that it shouldn't necessarily need to require. Okay, cool. The next kind of anomaly that can occur, because remember I told you there were three, is a delete anomaly. So this is like saying if we delete one type of data, we could lose other types of data. So for example, we could say over here, right? Let's say I deleted book 1 from the database. Okay, we no longer list book 1. The publisher of book 1 says that, look, you're no longer allowed to list the war poems of Sigrid Sassoon on your site or whatever, so we delete it from the website. Okay, so we delete book 1 from the website. The following day, the company comes and they ask us which genres of book have we had on our site since the beginning of time? Like since we started our site, which genres have we had on our site? You can now no longer tell them that information, right? Because even though you just deleted this book, you deleted the war poems of Sigrid Sassoon, the indirect results of that, like as a consequence of that, you also ended up deleting the genre of poetry. Okay. And so that's called a deletion anomaly. Like another thing you also deleted was the existence of the author, Sigrid Sassoon. You no longer knew about that author. You deleted one of his books, sure, that's fine. But hypothetically, you could still know that Sigrid Sassoon exists without knowing that this was his book or without listing his book in your database. You could just list him as an author with no books, hypothetically, like no books that you have access to. So that's a deletion anomaly, where deleting one piece of data causes other types of data that you didn't necessarily want to be deleted. Okay, so that's the second kind of anomaly that we can run into. And the last kind of anomaly that we can run into is called an update anomaly. Okay, an update anomaly. This one's more to do around efficiency. Okay, so for example, let's say I said, all right, guys, I want to replace fiction with literary fiction. Okay, like the fiction genre, that's a little bit too vague. We want to call it literary fiction. So if I want to update the fiction genre to literary fiction, I have to update this part of the table, this item. I also have to update this item. In order to update one piece of information, I need to update 2 rows of the table. And you can imagine if we had 100,000 books in our database, this would be hugely inefficient and very annoying, right? Like you don't want to actually have to search through the whole database to change this one piece of information. You just want to change it in one place somewhere, and everything that's fiction must just know that it's now literary fiction. Okay, that's called an update anomaly. And think about it, there are other ways that this could occur, right? Like let's say, so that's the best case scenario, is that you update this to literary fiction and you know that you must also update this to literary fiction. But there is a way that you could implement this incorrectly where only one of these things is updated. And so then you have some data that's outdated. Okay, that's an update anomaly. So where either you updating something requires you to update multiple rows, or you forget to update certain things. So certain things that should have been updated weren't. Okay, so that's the 2 ways that error can occur, that anomaly can occur, the update anomaly. Okay, so from this fairly innocuous table that seemed fairly good as a table, right? I think you'll agree it seemed to be working as a database fairly effectively. Even this is very wrong for a lot of reasons. This is not how you would do this. This is not a well-designed database. So we're going to see what steps we have to follow in order to resolve those problems, okay? And the steps we have to go through together, they're called normalization. Okay, but we'll discuss this when we come back from a little break. I think let's break until 15:55 since we're making pretty good time. I'm going to go get a glass of water quickly because I definitely need one. And then I'll be back. Okay. So see you guys in a bit. Yeah, I think most people watch the YouTube videos now, James. Which, I mean, I hope it works out for them. Occasionally. Usually they'll WhatsApp me instead, though, privately, when people have questions. Hmm. No. So we'll get a classroom at your school, Creflo, or at another school, like we'd host multiple people. And you would go sit in the classroom, Microsoft, some guy will come from Microsoft and bring a laptop and you'll write on that laptop. That's how you'll write your final exam. And we have like a little desktop application that will ask you some randomized questions. 35 randomized questions, I think there are. Stressed. No, don't worry too much. We'll do revision lectures. There's a good chance that you guys will do okay if you study, because we'll do a lot of revision and stuff. Got some time before you write. It will take work, but I think you guys can do it. Have you heard of Pirate Bay, Jones? this would be a good place to get a free copy of Microsoft Office, because it is pricey actually. Usually nowadays, when you buy like a new laptop or whatever, it'll just come with it. What do you need Office for, though? Schoolwork. I mean, you could use Google Drive. You do Cat. So what does Cat still cover like Access or whatever? Like those weird things? Because if you're doing Excel, okay. So if you need Microsoft Access, that's a bit weird. But I mean, like Excel and stuff, well, you can use Google Sheets instead for that sort of thing. But yeah, for some of the other stuff, you definitely need a Microsoft Office in order to practice. That too. I mean, there's also Linux. Ubuntu has some like LibreOffice and LibreDocs, or Libre Sheets, I think it's called. So that's free and can do most of the things Office can do. But yeah, no, if you're covering Microsoft Access, like the database thing, then you probably need a thingy. Can you run Linux from your USB? Yeah, you can, Creflo. Yeah. Just download UNetBootin. And then you just download like whatever distro of Linux you want. If you're just starting, probably Ubuntu would be best. And just create a bootable drive. And then you just plug it into your computer. You'll have to like slam F12 or F11 or F2 to open up the boot menu and select the USB drive that you want to boot from. And you'll boot into Ubuntu and you can try it out. Or Kali. I guess you would like Kali Linux, Creflo. That's unfortunate, Jones. Load shedding too. Has load shedding started again? That's annoying. Let me check my schedule. No, okay, I'm not load shedding this week. Yeah, Ubuntu is nicest for beginners. Yeah, do that. Rish. Okay, bye-bye, Jones. Cool. Let's jump in. So, great. Essentially, so to solve all three of these problems, we do a process called normalization, okay, or we perform normalization on the database. And there's essentially just 3 steps or 3 rules, okay? Each one of them is called a normal form. So normal just being short for normalization, I guess. So each one is just called a normal form. So there's first normal form, second normal form, third normal form. And once you get your database into third normal form, all of these anomalies on the left will be solved. Okay, you'll no longer have any of those problems. It can be quite a hassle to get something into third normal form, and you do have to think about it and use your intuition a bit. Again, like with the little database we just built, there's a different example in your book. So you have access to multiple examples. Okay, guys. So let's jump in to first normal form. So first normal form is super simple. Okay, it's a very simple rule that you just apply to get a database into first normal form. The first rule is for a table to be in 1NF, so for a table to be in first normal form, none of its columns should contain multiple values. None of its columns should contain multiple values. So let's take a look at our database over here. That's our table. Can anyone tell me where's the problem, guys? Is this database in first normal form? If it's not in first normal form, what's the problem? The numbers. None of its columns should contain multiple values, multiple different values. So let's see. Read more, Teddy. Read more. Check out the table. What's wrong with it? Which column contains multiple values? Column. Hey, which column? 1, 1, 2, 2. Let's see. So let me think. 1. ID and genre ID. Oh, okay. No, but remember, those are different columns, Taddy. Those are different columns. So ID is a separate column, and each field in ID only contains one number, right? Title looks fine to me as well, right? So in title, each 1, 2, 2. So remember that column still, each field, 1 is just one number, 2 is just one number, the other 2 is just one number. Genre looks okay as well, right? Because it's just poetry. So that's one entry, one value, one string, poetry. Fiction, that's one string. Fiction, that's one string. But where might we have a problem in this? We've eliminated basically all of the columns now, right? So it's not ID. It's not genre ID. It's not genre. Where do you see like multiple values? What here could count as multiple values? Title. So, I mean, each title, it's one string, right? So the War Poems of Sigrid Sassoon, that's one title. That's cool. Metamorphosis, that's one. Grimm's Fairy Tales, that's one. Even most of author looks okay as well, right? Sigrid Sassoon, that's fine. Franz Kafka, that's fine. Jacob Grimm, comma, Wilhelm Grimm. This is what we mean by multiple values, okay? Jacob Grimm, comma, Wilhelm Grimm. There's 2 authors, okay? So some books have 2 authors, and one of those books happens to be in our table, which will break things. So if I ask you to find the author of each book or the surname of each author, this can cause serious issues, okay? Or like if I asked you, how many authors are in this table? How many authors are there listed in this table? The answer is what? 3 or 4? So that causes a serious issue, okay? If you want to update the way you list an author's name to be, instead of listing their full first name, you just list their like initial, just their initial, like S. Sassoon or F. Kafka or J. Grimm. This will also cause troubles because where's the initial is basically the problem. Okay, so there we go. That was the issue. That's the only reason this table is not in first normal form. If this table, if the third entry in this table, okay, welcome back, Kreflo. We're just discussing first normal form. So first normal form, none of the table's columns must contain multiple values. And you can see here, Jacob Grimm, Wilhelm Grimm, this column, the author column, contains multiple values, okay? So yeah, if this entry was just a book that has one author, then this table would actually be in first normal form. That would be okay. So yeah, it is. It does rely a little bit on your intuition about what kind of data you're storing, and in this case, it was just happens to be the case. So, some of the books that we're storing do have multiple values. Okay, so how do we solve this? It's actually pretty simple to solve this. You just remove the author column. Okay, but now you might be like, okay, no, this clearly did not solve the problem because now our books don't have authors. That doesn't seem to be solving the problem. And this is where it gets a little freaky. So you create another table for authors. Okay. You create another table for authors. So you can see we've got an author ID, so we can uniquely identify each field. And then each author stores the book that they write. Okay, so Sigrid Sassoon wrote book ID 1, The War Poems of Sigrid Sassoon. Wilhelm Grimm wrote book ID 3. Jacob Grimm wrote book ID 3. Okay. Now, there are like maybe other problems like this because you can think like, what if an author writes multiple books? Then we'll have another problem because book ID would contain multiple values, and you could solve that as well. But the big thing is just for this particular database, which is a fairly narrow example where each author only contributes to one book, this would be fine. Okay, it does rely. So guys, database design relies heavily, and I imagine you could guess that it would, relies heavily on the type of data that you're storing and the way that you are structuring that data. Okay, so for this particular use case, this is fine. None of our columns contain multiple values. The database is in first normal form. Okay, and you can see we still have a relationship between our authors and our books. Okay, and by the way, I didn't have to separate this into first name and last name. That was just me doing it. Okay, I just did that because it's better that way. Okay, cool, but that didn't have to be done. Cool, so that's it. I mean, again, you could hypothetically say that it's containing two names because it contains Siegfried and Sassoon, so that's technically two names. So that could be multiple values, but that's not necessarily by definition. Okay, it depends whether or not you're treating the names as two entries. But yeah, database design, you'll notice frequently does rely on this kind of logic, like this reasoning out, this intuition. Okay. Cool. So that's the first normal form. Hopefully you can agree. I mean, there are some finicky things like I just mentioned, but hopefully you can agree it's pretty easy to identify now that you know when a column contains multiple values. Usually, guys, what you can do is you can look for a comma. Okay. If there's a comma somewhere in one of the columns, that likely means that that column contains multiple values, and therefore the database is not in first normal form. So that's a little trick. Look for a comma. Okay, just look for a comma. And you can see that that would also work on, like there's an example of first normal form, a difference example of first normal form on page 147 of your textbooks. And you can see the comma trick would work there. But also you can see under phone number, some of the fields in phone number contain two different entries, like two phone numbers. And in such a case, it's fairly clear, you know, that's multiple values. Okay, cool. So that's the first normal form. Nothing too bad. They do get a little bit more hectic. And in fact, before understanding second normal form, I'm going to have to introduce you guys to two new ideas. The first of these ideas is functional dependence. Functional dependence. Now, I got a little bit tongue twisted the last time I was explaining this to a school, so I'm going to try not let that happen this time. So functional dependence, they don't give a clear definition in your book. This definition does work. It's Y being functionally dependent on X means that the value of X uniquely determines the value of Y. Okay, so essentially, if you want to think about it in a picture, what this means, functional dependence means that X implies Y. Okay, it's only one way. It has a direction, so Y doesn't have to imply X, okay, but X has to imply Y. So the simplest way to understand this is that every single column in a table will be functionally dependent on the ID, okay, on the primary key, rather, I should say. Every single column in your table will be functionally dependent on the primary key. Why do I say that? Because the primary key, oh, sorry about this, I've lost my mouse. Okay, there it is. The primary key can uniquely determine each row, right? So if I know that I'm talking about a book with ID 1, okay, 1 will only specify one title, for example, right? So let's say hypothetically, if there was another entry in our database with like a 1, and the title this time was Alice, okay? Like Alice in Wonderland, for example. Let me just type it because that'll be easier. So I'm just going to say, let's say the title of book 1, there was a 1 with the War Poems of Siegfried Sassoon, and there was a 1 with Alice, okay? A 1 with Alice over here, okay? So you can see now that the ID of 1 is specifying two different titles, okay? And in that scenario, it wouldn't be functionally dependent, okay? So essentially what this is saying is that it has to specify something unique, okay? one can only specify one title. Okay, it can only specify one poetry. It has to be deterministic. If I know the ID is 1, then I have to know everything else about that record. And if that's true, then there is functional dependence between those columns. Okay, so ID is also functionally, genre is functionally dependent on ID. If you know that the ID is 1, then you know that the genre is poetry. Okay, there is no contradiction. There is no other field with 1 that has a different genre. Okay, if you know that the ID is 2, you know that the genre is fiction. Okay, if you know that the ID is 3, then you know that the genre is fiction. Okay, it doesn't matter that 2 specifies fiction and 3 specifies fiction. That's fine. Okay, because we're not saying that X is functionally dependent on Y. So this is our X over here. And this is our Y. Okay. Again, forgive the handwriting. I'm using my trackpad. So we're not talking about X being functionally dependent on Y. In that case, that wouldn't be the case, right? Because there is a book with fiction that has an ID of 2, and there's a book with fiction that has an ID of 3. So the functional dependence is not reversible. It only goes one way. 1, 2, 3, poetry, fiction, fiction. That's fine. Okay. 2 specifies fiction, 3 specifies fiction. What matters is that there's not another 2 specifying poetry or something. Okay. So we can say that Y is functionally dependent on X. And you can see in this particular table, that also applies for title, actually, because every single book has a unique title. But remember, that's not like intuitive, okay? There could be, hypothetically, another book somewhere in the database that has the same title, and so we wouldn't necessarily make claims. In this specific set of data, you could make claims of functional dependence, but we wouldn't. Okay, now. So let's see an example of what wouldn't be functional dependence. So, for example, genre ID. Okay. We can say that if genre ID is X and title is Y, if we make genre ID X and title Y, we can see that X does not, like Y is not functionally dependent on X. X does not determine Y, right? And you guys can see where the contradiction is. If I know that the genre ID is 2, the title could either be Metamorphosis or it could be Grimm's Fairy Tales. And so X does not uniquely determine Y in this case. Okay, so there we go. That's functional dependence, guys. If you remember this definition at the top, I think you'll be able to adjust to most scenarios. And the little thing that I'll send you after this as like homework, as like a little exercise, will probably make it even clearer for you guys. Okay, so that's functional dependence. Y being functionally dependent on X means that the value of X uniquely determines the value of Y. Okay, cool. So we can see everything in the database is functionally dependent on the ID. Okay, because the ID is the primary key. It can uniquely determine everything in the database. Notice though, guys, we also have a functional dependence between genre ID and genre, right? 1, poetry, 2, fiction, and 2 is always fiction. So there's also a functional dependence here, but we haven't really explored that yet. Okay, cool. So there's functional dependence, guys. Then we have the idea of composite keys as well. So currently, when I explain primary key, a primary key is the thing that uniquely identifies each record. You, as the programmer, can also specify a primary key that is made up of more than one column. So you see ID is underlined and animal ID is underlined. So that is called a composite key because it is a composite, right? It's made up of multiple different things. So it's a composite of columns. Okay, a composite key has more than one column. So here, ID and animal ID uniquely identifies each row. Okay, that's our primary key, is a combination of ID and animal ID, like a vector. So we have 1, 1, 2, 2, 3, 1. Those are our different rows in this case. Those are the, that's the key that would identify each row. 3, 1 would give you this row over here. Okay, so yeah. this is just a simple table of like animal sightings. And yeah, we decided to, in this case, define a composite key, which is a primary key that contains more than one, or a key that contains more than one column. Okay, cool. So once you know the idea of composite keys, so the idea that you can have more than one column in your primary key, and functional dependence, you can now understand second normal form. Second normal form is actually also quite easy. So for a table to be in 2NF, okay, so this is the second rule. For a table to be in 2NF, it must be in 1NF. Okay, cool. So that's the first thing. Your table has to be in 1NF. None of its columns must contain multiple values, okay, before you can be in second normal form. So in order to be in 2NF, you must be in 1NF. And so there's an extra condition now. So you must be in 1NF, and all non-key columns must be functionally dependent on the entire primary key. On the entire primary key. All non-key columns must be functionally dependent on the entire primary key. So number one, there's an easy way to remember this, guys. As I told you before, by definition, if you have only one column in your primary key, right? Well, actually, we can be more general than that. By definition, every single column in your database will be functionally dependent on the primary key. Every single column in your database will, by definition, be functionally dependent on your primary key, because you have to be able to uniquely identify each row by something, or then you don't even have a database. It's not organized, okay? So that's the first thing. So 2NF only applies. So in this case, if you ever have only one column in your primary key, so you see only ID is underlined here. If you ever have only one column in your primary key, then the database is in 1NF. So you only have one column in your primary key, and the database is in 1NF, then the database is automatically in 2NF. Okay. So let's think about this for a little while. So you can see all non-key columns must be functionally dependent on the entire primary key. Okay. You can see for this database, title is functionally dependent on ID. Genre ID is functionally dependent on ID. Genre is functionally dependent on ID. And ID is our entire primary key, because there's only one column in our primary key. Okay. So there you go. That's true. It's functionally dependent on the entire primary key. Okay, cool. So that example, fairly straightforward, I think. All 1NF tables with a single column as their key are also in 2NF. So this rule only needs to be considered when you have a composite key. So let's go back to our previous example of a composite key, where we have two columns in our primary key. Okay. In this case, we now don't know yet whether or not this table is in 2NF. We have to establish, are all non-key columns functionally dependent on the entire primary key? And the answer to that is actually no in this case. Okay, so you can see that animal ID is a part of our primary key, and ID is a part of our primary key. So we can see animal ID is functionally dependent on ID. That works. Date is functionally dependent on ID. So that works. Animal name is functionally dependent on ID. So that works. Okay. So the problem we run into here is that, number one, so ID is not our entire primary key. We also have to consider animal ID. Okay. And in this scenario, it's not anymore. Okay. You can see that if we have a 1, we don't know whether the date is the 28th of September or the 5th of October. We don't know. If we're just looking at 1, we don't know with which sighting we'll need. The animal ID doesn't uniquely determine each row. Okay. So this table is not in 2NF. There's a number of ways you could get it in 2NF. An easy way to do so would just be to like make it so that animal ID is no longer a part of the primary key. Okay. And just have like a separate table where you specify animals. Okay, cool. So that's second normal form. It only has to be considered when you have a composite key. And yeah, so all 1NF tables that only have one column in their primary key are automatically in 2NF. It only applies when you have a composite key, which in general, you probably shouldn't have a composite key because it's a bit annoying to work with, okay? But it's fairly easy to solve. You basically just remove the thing that shouldn't be in your primary key. Okay, cool. So the last normal form is third normal form, and you guys should already be able to understand it. This one's a pretty interesting one to identify and to picture. So third normal form, the rule is, again, pretty okay. For a table to be in 3NF, so for a table to be in third normal form, it must be in 2NF. Okay, and you remember, so for a table to be in 2NF, it must be in 1NF. So the higher level always implies the previous level. Okay, so third normal form implies second normal form. Second normal form implies first normal form. So third normal form implies both second and first normal form. Okay, so for a table to be in 3NF, it must be in 2NF, which means it must be in 1NF, and it mustn't have any all non-key columns must be functionally dependent on the entire primary key, and no column must contain multiple values. So that's the first thing. So unless we're in 2NF, we can't be in 3NF. And so there's that extra rule again. There must be no functional dependence between non-key attributes. There must be no functional dependence between non-key attributes. So if a column is not, so column and attribute, same thing, right? So if a column is not in your primary key, okay, it mustn't be functionally dependent on anything except your primary key. Okay, so this rule is very strict. So can one of you tell me, guys? So ID is the primary key here. Remember, so ID is the primary key here. So what's the problem, guys? What's the problem with this database? Is this in 3NF? Is this in 3NF? If not, what is the very glaring error? It's not, right? Yeah, because there is, yeah, the genre ID, exactly. Okay, cool. Tadi, you seem to have got it. That's fantastic. I hope the rest of you are also following. So you can see genre ID uniquely determines genre, okay? Genre is not in the key. Genre ID is not in the key. Exactly, Tadi, exactly. So genre ID is not in our primary key. Genre is not in our primary key, but there is functional dependence between them. And it says there must be no functional dependence between non-key attributes. So how do we fix this? It's actually fairly easy to fix this. You'll see now. So once again, we have to create another table. This one will be a fairly simple table that just contains our genres, okay? So what we'll do is we'll create a, sorry, let me just erase that little red mark or it'll drive me crazy. There we go. So oh no, there's another red mark. So what we'll do, we'll remove the genre's name from the table. Okay, and you'll see, so you can see we're ending up with a very small table. We're ending up with a very small table, but you'll see that it'll work much better. And we'll create a second table called genre. Okay, like so. All right, now technically you could say, so title is not in the primary key, like we did discuss earlier, and this does rely on your intuition a little bit, guys. So I want to tell you that, like, be upfront with you about that. Like, this is not, it's not a totally perfect concept, right? Like there is some intuition, some understanding that is required of like what kind of data you're storing. Technically, title does kind of currently, like you could just use title as the primary key in a way. And currently it's not in the key, so this is violating 3NF, but that doesn't play in because you can picture a situation where two books would have the same title. So you don't have to be that strict. It's when it's clear, like you must rely on your intuition and your understanding a little bit here. Okay. Technically you could split these again, but that would just be, it would be getting a bit crazy for this level course. But you'll also see some more examples of this, and it'll become second nature. It seems like, Taddy, you already got it. You knew that we would split this into another table. In a way, you would have even another table that just has the ID of the items. Doesn't seem hard, just repetitive in terms of, yeah, exactly. It's not difficult. It's just repetitive. And you can constantly apply these rules. You can constantly, again and again, you'd be applying these rules. Yeah. Interesting stuff. Okay, cool. So great. So this solves our problem. There's now no functional dependence between non-key attributes. You can picture, let's just say we have another title that just matches one of our previous titles, which is not a difficult thing to imagine happening in a book, right? There'd be at least two books with the title Software Development Fundamentals. Okay, let's say that. Book 4 is Software Development Fundamentals, and book 5 is also another book with the same title. Okay, and then we could add another genre, like genre 3 coursework or education. So can you still help me with NPM? Yes, yeah, 100%, Creflo. We can do that afterwards. Cool. So yeah, that's that. That's third normal form. And that's it for our introductory lecture on databases. I see we finished a little bit early. So what I'm going to do, I'm going to post a thing, guys. It was made by Brighter Futures. I haven't actually gone through it yet. I'll be going through it while you guys are going through it. But it's basically like a little walkthrough or like a project kind of thing, a game that'll teach you about databases. Okay, so I'll send that on the group. I want you to finish it before our next lecture. Okay. Yeah, exactly. So it'll reinforce what you learned today, precisely. So that's what I'll send. I'll post it in the WhatsApp group and on Discord after the lecture, along with the lecture recording. Okay. I'll also put it in the description of the lecture recording. But yeah, otherwise we are done for today, guys. So nicely done. And yeah, I guess I'll see you all next time. And yeah, cool. That's that.